Okay, guys, got to be thinking about the incoming solar wind and the effect it has on us here through the magnetosphere, charging the ionosphere, and the free energy that it provides that we can harvest. And now they're starting to find even heavy wave or gravity wave energy that's available to us freely in space also. But let's take a look here. This is something. Got to remember that the Earth's magnetosphere now is basically, exciting the solar wind as it comes in. This is the result in the aurora borealis or northern lights. But this is energy, basically energy coming into the Earth battery. Likewise, without the magnetosphere, you know what happens to us, huh? Solar wind torches us. Basically would decimate, would just burn us up. So the different light levels, different colors indicate different excitement of the particles coming in. Generally the visible spectrum white, kind of right in the middle, but then you got the blues and reds, and then you go in the opposite direction to the invisible on both ends of the spectrum. So that we're just seeing a small portion of the energy that's coming in. Yeah, beautiful, isn't it? So what good is that stuff? What good is that Aurora Borealis? As we saw in one of the earlier lectures with the Tesla, with the laser weapon, Tesla also had some concepts as far as, free energy for the world, the Earth Bank or Earth Battery, all based in geomagnetics. And there's one theory that currently seems to be some scientific data that indicates possibility of rapid geomagnetic reversal.
Observers, per previous instructions, I'll assume you are relatively caught up on the basics of Earth's electromagnetic condition. In case there are any newcomers to the channel, here's a bit of review of what
A little buffering issue, sorry about that.
where we stand. There have been more than 50 publications detailing how Earth's magnetosphere, our planetary magnetic shield,
Might have to refresh this.
is weakening. There have been more than 50 publications detailing how
Let's try it
Earth's
again here.
magnetosphere, our planetary magnetic shield, is weakening. These are just a few. The WDC for Geomagnetism in Kyoto, Japan has created this animation showing how Earth's magnetic field is fading quite quickly. In this animation, white and pink are strong protective fields, and blue and violet are the weaker fields. Back in 2011, the European Space Agency confirmed that our field had lost about 15% of its protective magnetism. In a world seemingly on the constant brink of war, where it's hard to agree on anything, nearly every country and scientist who studies our magnetosphere manages to come to the same conclusion. It is fading fast. The ESA's Swarm satellite mission has been keeping us updated. As of this year, the field is still weakening, faster and faster. Some commenters suggest we could have lost 20% or more of our protection at this point. The mission manager from Swarm said that the field is likely weakening because the poles are getting ready to flip, which, by the way, all scientists also agree is long overdue on Earth. But in literally the very next sentence, it is claimed that this will take thousands of years. However, as NASA reported back in 2003, the poles have already begun shifting, and they are not taking their time. The shifting of the poles is taking the same speedy approach that our magnetosphere is taking, faster and faster, and the guess from 2010 of where we'd be in 2015 is already considered well short of actual movement. At this time, the poles are moving at least 65 kilometers per year, and probably faster by now, which puts Earth's full reversal only decades away, assuming it doesn't speed up anymore. If it does continue to speed up, we could be much closer. Could a reversal truly take place within our lifetimes? Absolutely. The newest information comes from Berkeley, not the folks to ignore, and they say the reversal can happen in a very short time period. This latest study shows a slow ramp up to a rapid shift and tipping point. This makes a process that happens 10 times faster than anyone else has predicted. The poles began shifting fast in the middle of the last century. The magnetosphere began weakening even earlier, and it turns out that this process can take less than 100 years total. Perhaps most importantly is confirmation of what the ESA said months ago. The magnetic field weakening precedes the pole flip. We'll get our next measurement of polar position next year, 2015. Meanwhile, the shield above our heads continues to fade, and the needle on your compass will point north in ever different directions. All we can do now is wait, hope the flip holds off longer than it already has, and hope the sun doesn't take advantage of our lack of protection.
So we're looking at, if you get a chance here, look at the sun's magnetic field flips. This is also back in topic 10. We didn't get to it in last week's lecture. You can see here we got the week 10 midterm exam, and I can see we've had that some of you guys are taking it already. Do well with that. I think you should be able to get a really good grade on that if you spend a little time on it. So at your leisure, please delve into that. And then we were looking at the generation of geomagnetic or geoelectrical energy, the Earth battery associated with the solar wind. And last year, the sun's magnetic field flipped, and when it did that, which it does, it's not that unusual, but when it did that, the eruption of Steamboat Geyser was, they think, was correlated with that, and there was other geothermal features in Yellowstone fired up, and so we're thinking that it stirred up the magma and the mantle of the Earth in general. So let's take a look here. Oh, they're not showing us that one anymore, sorry. Let's get rid of that. I'll try to find that in a different link for you, so I'll provide that. But the fact that the space, the solar wind, and the spinning of the Earth, if you get a chance here, take a look and see what, if the Earth stops spinning, what happens if the Earth stops spinning. You know, it's could be a bad deal. And if the magnetic poles are starting to change and the magnetosphere is being affected, and that they're able to quantify that, then might be time to kind of dig a hole and take advantage of geothermal energy, huh? Looks like we're having a buffering issue here on campus today.
Is 6 months long.
While here in Miami, we're being blanketed by snow again today.
And every day is 6 months too. And the planet is scorched by a relentless sun.
Today's solar radiation index is extremely high.
It's a world where cities have been swallowed by the sea, and others have been all but deserted, the air too thin to breathe. It's a world where we face a desperate future, struggling to survive in an alien landscape.
You need rotation for a phototropic period and
This is the story.
creation, distribution of heat, creation of and sustainability of the magnetosphere. Remember the rotation of dynamo. And then we start to think about toroidal energy, which we're going to look at in the future. So this is a kind of a peek at the future of geothermal energy. It's not all just about heat and, you know, heating your house and making electricity out of steam. The geothermal energy also generates the magnetosphere, which is basically a huge battery, and that information through the Teslonian theory, we can harvest that energy. And we'll talk more about that in the future with toroidal energy. I'll get down in here to cold fusion, and then Keisha and his concepts of gravity wave, which, by the way, they're building a new gravity wave lab in Bozeman at the university there. Yeah, Montana State. Yeah, Bobcats, huh? Nah, we're Grizzlies. We want to take a look now, too, at some of the different larger organizations. Geothermal hotspots. Going to look into the GRC, forward thinking. Geothermal Resource Council, right here. Take a peek in there. Oramat stocks, Raleigh geothermal wells, and then the Geothermal Kenya and geothermal in El Salvador, which are all steam electricity generating plants. So stay tuned. We'll take a look into some of these. But appreciate your thoughts as far as what is the potential of geothermal, geomagnetic, toroidal energy. Remember, we got that term paper. So be thinking about some good stuff. Looking forward to some genius revelation from you guys.